Hi there, welcome back to the King's Tutorial class. I believe you'll be watching the videos I'll be uploading on my YouTube channel. Okay, so on to the next question. I have I have from 11 down to like 16, 17, 18. Now follow through as I explain what you do to solve the question. Now for number 10 question, we'll be able to answer that question already on my channel. For number 11, now the question says the equation 3x squared plus 3kx plus k equals 0, where k is non-zero, is a non-zero constant, and has alpha and beta as the roots. I'm to find the quadratic equation whose roots are this and this. Now very simple. The thing I have to do here is to use the formula for roots of quadratic equation. I'm to use that formula, and that is x squared minus sum of roots times x, then plus what, product of roots, all equals to 0. In that case, then this first value that I have here is my alpha. Let's say that's my alpha. The second one is my beta. So I have to first do sum of root, that is alpha plus beta. So I'm going to be doing alpha squared over beta times all what we have there, plus beta squared over alpha times all what we have there. Whatever you get after finding the LCM and solving, you will now put the values of your alpha plus beta from your equation that is given up here. Now, sum of roots from the equation 3x squared plus 3kx plus k equals 0. The sum of roots there is what? Minus b over a, which is minus 3k over what? Over 3. And that's minus k. And the product of roots, which is c over a, becomes what? K over 3. Now, for the product of roots for this gigantic roots of equation, after doing the sum, we're going to also do the product. So you have to multiply these two gigantic values together. After doing that, then you would put it inside the equation I gave earlier, which is x squared minus sum of roots times x plus what, product of roots, all equals to 0, and you solve and get your what, your final answer. Number 12. If alpha beta are the roots of the equation this, then I'm to do what? I am to find the equation whose roots are this and this, expressing the coefficients in terms of a, b, and c. The same method also applies here. I'm going to find the equation whose root are this, add them, multiply them, and then input inside this gigantic equation kind of also. So as simple as that, then you should get your answer. Number 13, it says find the range of values of k which the equation this equals 0 has real distinct roots, and number 2, roots of the same sign. Now very simple. For the first one is when your b square is greater than or equals greater than is not really equal. So is when your b is strictly greater than 4ac. That's b square is greater than 4ac. That is, your b here is what, k minus 3. So you're going to square that to be greater than what, 4 times my a is 1, my c is what, is k. Then I have, for the second one, roots of the same sign. Now for root of the same sign, is when my b square equals to 4ac. So just like using that, we have equal roots here, in which case I'm going to have k minus 3 all squared equals to 4 times 1 times k. So after expanding, then you solve for your k, whatever the values are, that gives you your final answer. Just to kind of do a recap again, number 11, you are going to be adding this gigantic one with the gigantic second one to get your sum of roots. Then you multiply those two gigantic numbers to get your product of roots. Then you put it into the equation. Before putting into the equation of roots, you have to first substitute your normal alpha plus beta and alpha beta in this equation 3x squared plus 3kx plus k equals 0, which your sum of root again is what, minus 3 over 3, which is minus k, and your product of roots is what, k over 3. After doing that, then you now substitute the final answer you're going to get from there into the equation of root, which is x squared minus sum of roots times x, then plus what, product of roots. The same thing goes for number 12. You are adding this less gigantic number to themselves, multiplying them, substituting value of alpha plus beta and alpha beta into that expression, and then substituting your sum of roots, your new sum of roots and product of roots into the quadratic equation of what, of roots. For the final one, just to use b squared to be greater than 4ac for the first question. Second question is b squared to be equals to 4ac, and you get your what answer. Now moving on to the next question, what do we have? Now we have form the equation whose roots are the square of the roots this. Form the equation whose roots are the square of the roots this. Now very simple. You have to square your alpha and beta and then get a new equation then. So first you have to do here is what? You have to first find your alpha plus beta and alpha beta. Alpha plus beta here is going to be b over a minus b over a, I mean, and alpha beta, which is product of roots, is what? Is c over a, our normal quadratic solution. Now from which you are now to square alpha, square beta, then you would add them together, multiply them together, they become your new sum of roots and product of roots. After which you perform some operations of quadratic expressions, that is alpha squared plus beta squared becomes what? Alpha plus beta all squared minus 2 alpha beta. From there you get your new alpha plus beta, which is alpha squared plus beta squared, and you get your new alpha squared beta squared, which is your product of roots. And then you now substitute it into your general formula for quadratic roots. Number 15, for what values of k ask the equation this to be equal? The same idea, bring what's at your right hand to your left, or what's at your left to your right, solve, equate it to 0, and then put it in a quadratic expression form, equating it to 0, and then factor out your, or pull out your a, your b, and your c. A, the one whose variable size power is 2, b, the one whose variable size power is 1, and c, the one whose variable size power is is a constant actually itself. So then after doing that, then you're now to solve for k. For what value of k has the equation to be equal? How do you then solve for k? Equal root is what? B square equals 4ac. You get your answer. Number 16, the roots of the equation this are alpha and beta. Very good. Given that the roots differ by this and the sum of the reciprocal of the roots is this, that's the new reciprocal or the new roots. First, what am I to do? Given that the roots of this equation differs by this, that is alpha, which is the first root, minus 2 root 3, and beta, which is the second root, minus 2 root 3, that's the first thing. Then they now said the sum of those new roots, the sum of their reciprocal equals to 4. That is 1 over alpha minus 2 root 3 plus 1 over beta minus 2 root 3. The answer equals to what? 4. Find the LCM and then find the expression, or find values of p and q respectively, after putting your alpha plus beta as what? Minus p over 1, and your alpha beta to be what? Q over 1. As simple as that. Number 17, if r is the ratio of the equation this, what am I then to do? If r is the ratio of the equation this, show that r squared, r plus 1 all squared times ac equals to b squared r. Now, in this case, what will I first do? Okay, so when they say r is the ratio of the quadratic equation ax squared plus bx plus c equals 0, means that my r is the same thing as what? Alpha over what? Over beta. Now, where you know my alpha to be b plus the square root of b squared minus 4ac over 2a, and we have our beta to be what? B minus the square root of what? B squared minus 4ac all over 2a. Actually, this should be minus. Now, from here, what do I then have? It means that these two cancel themselves, leaving my answer to be what? R to be equals to minus b plus the square root of what? B squared minus 4ac over minus b minus the square root of what? B squared minus what? 4ac. Now, this is the same thing as b minus the square root of b squared minus 4ac over b plus the square root of b squared minus 4ac. Why? Because if I bring on minus, what happens? This becomes plus, minus, plus, plus. They cancel out. Okay, so now from here, what do I then have? I'm now to show that what? R plus 1 all squared times ac is equals to b squared r. In this case, what it means then becomes what? Let's do r plus 1 first. Doing r plus 1 becomes what? B minus the square root of b squared minus 4ac over b plus the square root of b squared minus 4ac plus what? Plus 1. Find the LCM. I'm going to have b minus square root of b squared minus 4ac over plus 1 times this becomes b plus the square root of what? B squared minus 4ac all over what? All over b plus the square root of b squared minus 4ac. Why? Because if this is over 1, it means that what? My LCM will be this times 1, which is this, and then this divided by this is 1. 1 times this gives us this. This divided by 1 is this. This times 1 gives us what? This back. Now on solving, this cancels this out, leaving me with what? 2b all over b plus what? The square root of what? B squared minus what? 4ac. And from here, what do I now do? I have to rationalize. So rationalizing, we have what? This as what? 2b over b plus the square root of b squared minus 4ac times b minus the square root of b squared minus 4ac over b minus the square root of what? B squared minus 4ac. Multiplying this must have to be what? 2b squared minus 2b the square root of what? That's this time this is 2b squared. This time this now becomes minus 2b the square root of b squared minus 4ac all over b squared minus b squared minus what? 4ac. Now this now becomes 2b squared minus 2b square root of what? B squared minus 4ac all over what? 4ac. Why? Because if I expand, this becomes b squared minus b squared plus 4ac. Okay, so nothing is common. Okay, something is common both up and down. I have 2 common up and down, so I'm going to have b squared minus what? B the square root of what? B squared minus 4ac all over 4ac. Now from here, I will now what? Perform the next operation or so. And what should be the next operation? I should what? I should square this solution. I should square r plus 1, which I just did now. Squaring it now becomes what? B squared minus b the square root of b squared minus 4ac times the same thing, b square root of b squared minus 4ac all over 16a squared c what? C squared. Now on solving, what will I have? Okay, so on solving, I have b raised power 4 minus 2b cubed square root of b squared minus 4ac plus b squared into all this. Now expanding, now it becomes what? It becomes b raised power 4 minus 2b raised power 3 square root of what? B squared minus 4ac, then plus what? B raised power 4 minus 4b squared ac plus b raised power 4 minus 4ab squared c. Okay, so over what? Over 16a squared c squared. 16a squared c squared. Now from here, what happens? This becomes 2b raised power what? Raised power 4 minus 2b cubed square root of what? B squared minus 4ac, then what remains? Minus 4ab squared c. Now all over what? 16a squared c squared. You will notice 2b squared is common up here, so it comes out as 2b squared. If 2b squared comes out here, then what now remains? What remains is what? B raised power 2 minus b square root of b squared minus 4ac, then minus 2ac all over what? If 2 comes out, what remains? What remains is 8a squared c squared. Now dividing, I have this as what? B squared into b squared minus b square root of b squared minus 4ac minus 2ac all over what? All over 8a squared c squared. Now this is what I got when I squared r plus 1. Now finally, multiplying by ac, what does that now become? It means this becomes times ac over 1. So leaving my answer to be what? B squared into b squared minus b the square root of b squared minus 4ac minus 2ac all over 8ac. And from here, this is what I actually have. So if they say I'm to prove that is equals to b squared r, I already have my b squared, so this possibly should be my r squared and my r in that case then. Okay, so now that's the solution for number 17. For number 18 now, for what value of m will the equation this have equal roots in magnitude but opposite sign? Now equal roots again is what? Is b squared equals 4ac. So you should know what to do. Take the right to the left or the left to the right, solve, and then get your answer. Number 19 now says if these are roots of this equation, form an equation with these roots. Now these are the first set of questions that we've done, or you should know what to do also in this case. Number 20, for what values of k does the equation this have equal roots? You should know what to do also in this case. And finally, if alpha beta are the roots of this equation, find this, and this. So the same idea goes here. You now know the expression for alpha cube minus beta cube. Alpha raised power 4 plus beta raised power 4. For alpha raised power 5 minus beta raised power 5, you can actually find that one out, when you expand. So that's all for this question.